Hello, my name is Marcus Bonner for Business Statistics 2, and in this video I'm going to be talking about the discrete probability distribution functions. So the task, purpose, and outcome. The task will be to select two discrete probability distribution concepts from the text and apply the real estate data to describe them. Purpose will be to explain the two discrete probability function concepts using the real estate data. And outcome will hopefully we'll be able to tell the difference between discrete and continuous probability and to understand how to describe future outcomes from given data. So I want to talk about what a probability distribution is first. So according to the text, it's defined as a list of all outcomes of an experiment and the probability associated with each outcome. The characteristics are that the probability of a particular outcome is between 0 and 1. Outcomes are mutually exclusive, and the list of all outcomes is exhaustive. So the sums of the probabilities are equal to 1. Continuing on with probability functions, they're categorized into two types. In order to further dive into discrete functions, we need to understand the difference between discrete and continuous. And on this slide, basically it describes what a discrete continuous function is. Discrete probability in a continuous. Discrete can only assume a certain number of specific values. Basically, it's a count. The book gives an example, the number of credit cards carried by a group of customers at a bank. So a number, a count. While continuous is just the result of some type of measurement. So like the length of each song on a CD. So in order to understand the difference, now that we know the difference between the two, we can talk about the discrete. On the next slide, now we'll go further into the discrete functions. The first one that I chose to describe is called a binomial distribution. So the question that I posed after reading about binomial distribution is, if there are 105 houses, what is the probability of owning a house with one pool? So binomial distributions have to fall into a set of rules. These are the 4 rules, and this is how it'll apply to the question. So the first rule is, are the outcomes mutually exclusive? Basically, either you own a house with one pool or you own a house with 0 pools. That's it. You can't own a house with 0 pools and 1 pool. Mutually exclusive. Second rule, the random variable is the number of quotations successes, or a house that has 1 pool out of the known quotations trial of 105 houses. So basically, the experiment was already done for us. Probability distribution assumes the probability of the likelihood of something else, of something happening. But in this case, the experiment has already happened. So that's why successes and trials have already have been quotated. I wanted to understate that. So number 3 rule, know the probability of success, and it's the same for each trial. So out of the 105 houses, there are 37 houses with 1 pool. So the probability of success is 35% chance. So out of those 105, 35% chance. And then also, lastly, each trial is independent. So basically, if we took another set of houses, it will not affect the first trial. All right, they're independent of each other. They won't affect each other. The second discussion point is the Poisson probability distribution. So the question that I posed here is, what is the number of houses with one garage? So the rule is, the variable is the number of times some event occurs during a defined interval. So the number of times I counted one garage during the interval being of 105 houses, all right, which was 71 times. So the probability of the event is proportional to the size of the interval. So the interval was 105, the event occurring was 71, definitely that's proportional. And lastly, the intervals are independent. So if we added more houses, it will not affect the intervals for the the number of times that I counted something over the first interval. So in conclusion, we talked about probability distribution. We further talked about the difference between discrete and continuous, and then we expanded upon what the 2 discrete distributions that I discussed in the book, binomial and Poisson distribution. Thank you for your time, and enjoy the rest of your day.